So the last three, they're now going to throw in some odd exponents. When you have an odd exponent, such as s to the 5th power, to do the square root, you're going to factor out one of my variables. So I'm going to rewrite s to the 5th as x to the 4th times s. I add my exponents, 4 plus 1 is 5. Now I can simplify the s to the 4th part of it, which is s squared times the square root of s. So whenever you have an odd exponent, you're going to have that extra one left underneath your square root sign. So thinking about simplifying this whole thing. Square root of 50. 50 is not a perfect square, so I would factor it. The biggest perfect square that goes into 50?
25.
25. So we make that 25 times 2. Then we look. This one has an odd exponent, so we rewrite it as s to the 4th times an s. That one has an even exponent, so we leave it alone because it is a perfect square, t to the 12th. Now that we've got it factored out how we need it, we can go ahead and take out our perfect squares. The square root of 25 is 5. The square root of s to the 4th would be s to the 2nd, half of my exponent, and then t to the 6th. The 2 and the s going to stay underneath my radical sign, so I get 5s squared t to the 6th square root of 2s. So number 13, I'm simplifying this one, and what do you know about 36? "36 is on your list of perfect squares, right? So I don't have to worry about factoring that one. I'm going to leave that alone. It is a perfect square. The t to the 7th, however, has an odd exponent, so I need to factor the t to the 7th. How do I factor that? T to the 6 times t. You're always just going to take 1 off of there, and then you have an even one. And then the u to the 10th has an even exponent. We leave that one alone. It is already a perfect square. So now when we take out our perfect squares, what are we going to have? 6t to the 3rd. And u to the 5th are all coming out. And what do we have left under our square root? Just a t. So 6t cubed u to the 5th square root of t would be my answer. So on occasion, they're going to give you a number here that's a perfect square, and people think, oh, I got to factor it every time. No, you only factor it if it's not a perfect square to begin with. And number 15, 54 is not a perfect square, so we do have to factor that one.
Was it
9 times 6. I know that's okay because 6 doesn't have any factors that are perfect squares, unlike when 8 did. So 9 times 6 would be our pair. Then we have x to the 11th. How would we want to redo that one?
X to the 10th times 1.
X to the 10th times an x. And then we have w to the 9th.
W to the 8th times W.
W to the 8th times w. So whenever they're odd, you're going to just take one out, and then you've got some perfect squares. So taking out our perfect squares, we can do 3 square root of 9, x to the 5th is the square root of x to the 10th, and w to the 4th is the square root of w to the 8th. Whoops, and then I wrote an 8 instead of a 4. How about I write a 4 there?
3xw inside the square.
Whoops.
Wait. 2.
This is just going to stay
Oh, 6.
6. So 6xw. Can't do anything with those underneath. So we get 3x to the 5th, w to the 4th times the square root of 6xw. All right, that should be the next 5 things in Chapter 6, which is that purple section there on your pie chart. We'll go ahead and work till about 10 and do the next page.